In match problem 5, we have another case where the function that's taking on the larger function values switches over the course of the interval that we're considering. So in this case, g of x equals 4 minus 2x, or actually let's start with f of x equals 2x squared. We're considering the interval from -2 to 2. So for the beginning part of this interval, our function 2x squared is taking on the smaller function values, and 4x minus 2 is taking on the larger function values. Then we hit this point, and that switches. G of x starts taking on the smaller function values, and f of x starts taking on the larger function values. So we're interested in finding the area under this curve, or area bounded between these two curves, I should say, from -2 to 2, which means we want to find the area of this region and the area of this region. So again, what we need to find is that point where these two lines intersect, which again we could do algebraically or with your graphing calculator, and that's going to occur at x equals 1. So we'll have two separate integrals to set up and evaluate. Our first integral will go from -2 to +1, and we'll be integrating 4 minus 2x minus 2x squared. Since again on the first portion of this interval, g of x takes on the larger function values, f of x takes on the smaller function values, minus the integral from 1 to 2. So now our functions switch. F of x is taking on the larger function values, so we'll have 2x squared minus 4 minus 2x dx. So cleaning up those integrals a little bit, we'll have the integral from -2 to 1 of 4 minus 2x squared dx minus the integral from 1 to 2 of 2x squared minus 4 plus 2x dx. Integrating will give us 4x minus x squared, because this will be 2 times x squared over 2, so 2 over 2 is going to cancel, minus 2x cubed over 3, which would be evaluated from -2 to 1. And then, I'm sorry, I was subtracting these. These should both be added together because we want to add this area to this area. So I apologize there. So we want to add then the integral from 1 to 2. Or I'm sorry, we're done. We actually want to integrate this. So plus 2x squared over 3 minus 4x plus x squared, which will evaluate from x equals 1 to x equals 2. So again, we'd have to evaluate each of these at the upper and lower bounds, but we've gone through several examples of those over the past couple of modules. So from here, I would assume you can finish up the rest of this problem, but you should be able to get as your final result 38 thirds.